You're watching PowerNation.
It started as a bunch of Coyote parts on a couple of pallets.
It will end on the dyno, making big supercharged horsepower. Hey everyone, today in the shop we are excited to start a brand new engine project, and it is one you've been asking us to do.
Let us explain. Because of this engine's complexity, it makes it a little bit more expensive and a lot harder to find. So for months we've been scouring the internet, and we think we finally found a project that will work for us.
That being said, normally we would have the engine in the shop and on an engine stand so we could tear it down, evaluate it, and tell you what we're going to do. But this time, that's not going to happen. This pile of loose parts came to us as someone's unfinished project. It doesn't look like anything special now, but looks can be deceiving.
This is one of Ford's most popular late model high performance engines, the 5-liter Coyote. We've got some big horsepower plans for this bullet, but first we have to sort through the pile and see what we've got.
These look really nice.
Yeah, it looks ported.
Oh my God, they're heavy too. CNC ported.
Ooh.
And we have 2 engine blocks, so is there more than one engine here?
Yeah, I saw there's doubles of some stuff and not everything, so I don't know if he bought doubles or started with 2 engines or what. It's all kinds of stuff. You got that one. Yeah, I'll take this. Give me the heavy one.
Ah, yeah.
Looks like we have most of the stock accessory stuff.
Well, there's an entire stock engine that was tore down, allegedly.
Yeah,
so.
I see some doubles, so.
Well, there's 2 blocks.
We'll have to go through some of it, but I think we have most of it.
Yeah. It's an entirely new set of valves.
Manley's too, yeah. He's got a lot of nice parts.
Oh, yeah.
Throw that.
And the windage, there's a pickup and windage tray. Old oil pump, idlers.
Yeah, we might need some of that.
Yeah. Now this is a sleeved block. And then we got to look at the piston. Yet the pistons look really, really nice. And this one has been a line honed with studs.
Nice ARP studs. At least we have a good block to start with.
Yeah, no, it's a stock block, but it's a good stock block.
Yeah.
What I'm not seeing is any rods and pistons.
I think they're stuffed in that block.
What's in that right there?
Yeah, we got all the pistons, all the rods, some of the dowels we need. We won't use this one, but definitely has some of the stuff we need, so
Excellent.
take it over.
Careful. Lift your back, not your knees. This is what I'm looking forward to seeing.
Yeah, this is the part I'm excited to look at. Cut that open.
Whoa,
Whoa.
that's really red.
Oh yeah. I thought it was going to be like polished. Now we know what color the engine's going to be.
Yes, grab hold of that. Well, the good thing and the bad thing about getting a project that's been like this is you know most of what it is, right?
Yeah.
Pulley choices.
Yeah, looks like 3 3/4, 3 1/2, and 3 1/4. Cool, so we got some options there.
As we are going through our pallet full of parts, we're realizing 2 different things. 1, we have a lot of nice parts to work with, and 2, we are missing some key components that we have to get ordered. So our next move is to make a list of what we need and get it coming so we can get this engine together. Up next, the build begins with a race-ready rotating assembly.
Piston rings are frequently overlooked and often taken for granted, but if they're not sealing the cylinder effectively, you're not making horsepower. From OEM applications to high-performance bullets, there are several different ring materials and coatings that are available. Back in the day, cast iron rings were the go-to material, and as cylinder pressure and horsepower increased, different face coatings were added, like molybdenum, known as moly, which is sprayed on the ring face and then lapped for surface finish. Moly increases the lifespan of the ring and its sealing properties. In more extreme horsepower applications, a different kind of ring material is needed to hold up to the extra abuse, so various types of tool steel and stainless steel are used. These can have more exotic coatings, like several different kinds of nitriding. As ring manufacturing technology has improved, modern rings have gotten thinner and thinner to decrease friction and rotating resistance. But it is important to note that ring sizes are dictated by the piston ring lands. Most OEM replacement rings are designed to be installed right out of the box, but high-performance rings need to be file fit to the correct gap for the application. You can get different levels of ring filers depending on your budget. No matter what your application is, you can find the rings you need at Summit Racing Equipment. It took several hours, but all the pieces are sorted and all the parts we need for this Coyote build have been ordered. With the block and parts thoroughly cleaned, we can finally get started. Like every engine we build, the main and rod bearing clearances are set up specifically for the application. These are Clevite H-Series race bearings designed to handle high horsepower.
Before the crank goes in, the stock piston squirter plugs are reinstalled. This keeps more oil going to the engine bearings. The stock forged crankshaft is rumored to support up to 1,500 horsepower, more than enough for our needs. The crankshaft has been balanced as a rotating assembly. How did Darth Vader know what Luke Skywalker got him for Christmas?
How?
He felt his presence. Okay, ARP has some very specific instructions on how the torque sequence goes and what they're torqued to.
Yep.
The biggest mistake people make is they will assume that a fastener like an ARP is the same as a torque to yield, and they will take one and treat it like a torque to yield. That's why it's so important to follow the instructions on their torque sequence. The ARP fasteners are torqued in sequence to a final value of 80 pound-feet on the inner studs and 45 pound-feet on the outer studs and side bolts.
Because of the boosted application, the ring gap is set to 29 thousandths on the top ring and 31 thousandths on the second ring. The ring is squared in the bore with our Summit Racing adjustable ring squaring tool. It ensures accurate gap measurement. The block was honed for a set of custom DSS forged pistons. They have a thermal barrier on top and coated skirts for durability. They also feature their patented X-Groove technology, and heavy-duty wrist pins are included. The pistons are mated to heavy-duty Manley H-beam connecting rods. Wire locks retain the wrist pins.
Good.
All right, yep, now we're good.
Okay, so why do you have to torque the mains or tighten the mains down before you turn the crank, but on the rods, we're not torquing them and we're still turning it?
Well, when we assemble it like this, we actually snug them down, so it already makes the rod bores round, so we're okay to do that until we actually final torque them.
That is true, and you can do the same thing with a crank, but typically we will put the crank in, we'll just go ahead and just torque it. You can snug them up, and as long as something's snug, the bearing's round. You can't just loosey-goosey it in there and then turn it over. People will put a crank in without the caps on, and they'll spin it, and that's bad news bears right there, so. The bolts are torqued to 67 pound-feet, and the rod bolt stretch is checked with our ARP gauge. To accurately calculate compression ratio, we must CC the combustion chamber. It has a volume of 53.8 cc's. The stock phaser assemblies, which are designed for variable cam timing, are being removed. We're replacing them with CompCam's phaser lockout plates. They allow for easy mechanical adjustment of both camshafts' centerline.
Up next, the Coyote gets a custom spec supercharger, then it goes hunting for horses in the dyno cell.
It's time to move on to the oiling system on our Coyote, and just like an LS, these have an oil pump that's driven off the front of the crankshaft. But before we put the pump on, we're going to do a few upgrades that we picked up from Boundary Racing Pumps. Well, we can take the stock pump, which is a 2011 up, and we put some different gears and a different backing plate on it. It starts with the set of gears. They are dimensionally the same as the gears that came out, but have some distinct differences, like porting on the side, which will have less cavitation and more flow at high RPM, plus put less heat in the oil. They are also coated with a combination of Martinware and a cold finish that will have virtually no wear up to 13,000 RPM. Along with the gears, we're also adding their deep flow billet backplate, which also has the same coating on the inside and is made of steel, which is much more rigid than the aluminum one that came off it. The best part about all of this is the new parts go right in where the old parts were, and you're back in business. To ensure that the pump is properly centered, we'll insert 1.5 thousandths feeler gauges before torquing. The heads came to us completely machined but unassembled. Manley stainless steel valves are lubed with assembly grease and then slid into the guides. We're using a specialty valve spring compressor on our pack valve springs and our CompCam's retainers. This tool can even be used to change the springs with the engine still in the vehicle if needed. This is a more tedious process than building conventional cylinder heads, but the tool makes it easier, in part because it compresses two valve springs at the same time.
We're running Cometic's MLS 94mm by 40 thousandths thick head gaskets. Then our CNC ported heads can drop on. The heads go on the dowels, and only then do we install the head studs. If you try to do it the other way around, the studs can remove bits of aluminum from the heads during assembly, which can clog the threads, causing all kinds of problems. The studs are torqued in 3 stages to a final value of 100 pound-feet per ARP's instructions.
The stock hydraulic cam followers get some ultra slick assembly lube, then they are put back into place. They are a 2-to-1 ratio. Our new comp cams go into place, being sure to install them in the unloaded position. Once all 4 of the cams are installed, there is a lengthy process of timing and degreeing the cams. This is a crucial and complicated part of building the engine. Fortunately, CompCams provides detailed instructions to guide you along the way. The Coyote has 4 chain guides and 2 hydraulic actuators, keeping tension on the primary timing chains.
Grenade!
You shouldn't say grenade around an engine. Because the intake and exhaust valve have individual camshafts, you can set the center lines wherever you like. We are setting ours at 118 degrees center line on the exhaust and 112 degrees center line on the intake.
Next, the timing cover is bolted on. After that, we can drop in the factory oil pan gasket that doubles as a windage tray, followed by our oil pan. To give this engine a clean, classic look, we chose gloss black for everything. For compatibility with our supercharger setup, we're using the stock water pump.
Before we install the Gen 5 3-liter Whipple supercharger, it needs a little prep. We'll install the intake O-rings on the underside of the unit. Since the supplied intake bolts are hidden under the top, they'll receive blue thread locker gel for safety purposes. They are torqued to 106 pound-inches. Last to go on are the O-rings for the intercooler and supercharger top. We chose to use ARP 12-point stainless fasteners. They get torqued to 90 pound-inches.
We want to be conservative on our baseline run, so we'll go with the largest diameter pulley for the slowest amount of blower speed. It's a 3 3/4 diameter unit. With the complete front drive assembly in place, the 10-rib serpentine belt gets snaked on. Fuel is supplied by FIC's 1200cc injectors. These are needed to support the power numbers we're hoping to get. An SFI-approved billet flywheel from Summit Racing Equipment is a must for dyno safety purposes.
What makes this engine so easy to run is the Terminator X Max ECU from Holley. It's a simple plug-and-play system that can run our drive-by-wire throttle body, and all the tuning is done by the convenient touchscreen unit. Up next, we're hoping for 1,000 horsepower or more. Break-in was uneventful and everything seems to be behaving properly.
Yeah, that EFI learned pretty quick.
Yeah,
it's still idling. It's idling super smooth.
I love it. I love it. I love it. Now everything else goes just great. You know, we're gonna have a good day. So
yeah.
We are going to go from 4,000 to 7,500. Now I don't know how much boost it's going to have. I don't know anything. So I'm gonna leave the steps size at 450.
Okay.
Because I don't want to, because you can load it too much or not load it enough. And there's this. I think 450 is going to be a.
And we're still on pump gas.
Good balance.
So
that's the big kicker is the pump gas. So, all right,
well,
4,000 to 7,500.
See what she does.
At over 100 pounds of oil pressure, I can tell you that. Woo-hoo-hoo! Now we're talking.
Dang.
Boost. Boost kills me sometimes because it's so easy to make power. 811.8 horsepower at 7,500, 662.6 pound-feet of torque.
Look at that torque too. It's over 600, almost all the way to 7,000.
Air-fuel ratio, right at the target, right?
Oh yeah.
Keep it nice, fat, and sassy. It's a little on the rich side, but for pump gas, I'm definitely going to err on the side of too rich because it'll just hurt a little bit of power.
Yeah.
16 psi boost. That is a hell of a good start.
Yeah.
Right now.
Superchargers make everything easy. Just instant power.
Yeah, I guess.
For our baseline run, we were pretty conservative on timing. Now we're adding 2 degrees, giving us 28 degrees of total timing. With just a few presses on the touchscreen, the timing adjustment is complete.
We've already succeeded.
I know. I just want to see what we can do now.
Well, so do I. How about that? Okay. 844 horse pressures at 7,500.
Yep.
And 674.7 pound-feet.
Dang.
We have 2 pulley changes. I don't know if we should really go for the gusto and see if we can make a really large number, or we just kind of sneak up on it.
Well, we have 3.5 and a 3 1/4, and we're at a 3 750, so 3 3/4 right now.
Right.
I say we just jump to the small one. Let's just see what this thing can do.
Okay. You know, we are at 2.79 per cube on pump gas.
Yeah.
That is violent. And it's still got 100 pounds of oil pressure, so we'll get a little bit more oil temperature in it. All right, here's what we'll do. Mix up some hot gas, some good gas, and
we'll swap that pulley and
let's just pour the coals to it.
We'll see what she can do.
I mean, why wouldn't a guy?
Yeah, we got it on here. Let's find out. There you go.
The smaller the pulley, the faster the supercharger spins, bringing more air into the engine.
This is a big jump in pulley. That's a half inch of pulley.
Yeah, this
should make a big difference.
What is half inch of pulley worth, right? I know it's gonna be worth some big boost. So,
on this big blower, yeah.
All right, here we go. That was big.
See what I saw?
That was really big. That was really big. Did we do it? Yes!
Ooh.
1,003.
Holy moly! Look at the torque.
It only made $7.99 for torque. Almost.
I mean, that's 79.4. That's pretty much 800, but it's everywhere still.
This thing doesn't make under 700 pound-feet anywhere. Oh my
That is insane. That's like 3.3.
It's 3.31 if you do the math. And
Dang.
it still has 102 pounds of oil pressure. Keep in mind, this has the stock forward crankshaft in it, which is a good crank, right?
Yeah.
It's got a sleeved block, but still a stock forward block. We have some nice parts in it, but we've just taken an engine with basically stock architecture, put a big blower on it, and throw 21 pounds boost at it, and it makes 1,000 horse.
That's crazy. I mean, boost solves everything.
I
guess that's the truth.
I hate when that happens too. See, because everyone's like, well, you know, this particular engine, I bet this engine responds really well to boost. Well, I got news for you.
They all respond.
Everything
to boost.
responds well to boost, right?
But that's awesome. 303 inches. That's just wicked.
That I think I'd have to check, but I think this is the highest horsepower per cube engine that since I've been here we've done. So.
Yeah. Man, that's crazy.
All right, it doesn't get more successful than that. Nice job on that. For more information on anything you've seen today, head over to PowerNationTV.com.